Let's look at that. The third event C is such that A and C are independent and B and C are independent. Now, you see, this is very important. So A and B independent, meaning this is fixed. Between A and B is fixed. This tells you between A and C is also fixed. Okay. B and C is also fixed. So basically, they are all fixed in the diagram. Like meaning A union, in other words, right, you can actually find A union B union C for sure. Confirm plus short one. Because they're all fixed in the Venn diagram. Okay, so in this case, actually model method may be a bit difficult because you can't actually move the set around. But what's going on is actually the probability within all of them, right? They are like moving around. You imagine like each point, right? They are like people, they move around, like they migrate to other states and they just move to another area and stuff like that. Okay, so that's what's going on. But so same thing lah. Before you even do anything, right, you just consider 2 first. You don't go and hero and do 3. So you just do 2 first. I think that's the most sensible way to do it. So once you do it, really, you put is it A and B? A and B first. Okay, A and B. So A 0.5, they are independent, so that's pretty okay. This middle PA intersect B will just be 0.5 times 0.6. So this is 0.3. 0.3, okay. Then this will be 0.2 because we did take 0.5 minus 0.3, which is 0.2. Then B would just be 0.3. Outside will be 0.2. This look, yeah. So it's 0.3, 0.3, 0.2, 0.2. Okay, so it's pretty okay lah. I'm just considering A and B first. I don't even think about C. Now, when I talk about C, I'll use another color and I'll try and understand what's going on. So C comes into play. C is happens half of the time because it's 50%. And C is independent to A and B. So that's pretty okay. I am going to use maybe bright, maybe not orange because that one was hot pink. So, okay, great. This is C. Now, when C comes into play, C is 50%. Like I say, the relationship between A and C is fixed. B and C is fixed. Okay. So in other words, you could actually find out all the probability A. I think you can find A union B union C if you want to. Okay. If you want to lah, but because PA union B union C is PA plus PB plus PC minus PA intersect B minus PA intersect B, B intersect C, minus PA intersect C plus PA intersect B intersect C. Okay. Yeah. So, but you don't have this. Okay, that doesn't matter. Yeah, I don't have this one, but we don't really need this. I'm just saying that the relationship are fixed. So what we need to do now is we need to find PA intersect C first. We find this potato here and just see what is it. So this is PA times PC. PA is 0.5. PC is also 0.5. It happens to be 0.25. Just do that. This is 0.25. Okay. So maybe I'll just put this this here. This is 0.25. Okay. Then B intersect C, same thing. This will just be point. What's B? B is actually B is 0.6 times 0.5. This is 0.3. So this part here is 0.3. 0.3. Okay. Take note of that. Great. So once done, then I can just speed up. So here, what we're gonna do is actually, you need PA intersect B intersect C, right? So just let PA intersect B intersect C be X. Okay, this is X, so you just let X be in the middle. But actually, it's easier to let X be in the middle because X is the ever-changing parts. So if this is X, right? Okay, maybe I should use another color here. So let's say this is X. Okay, then obviously this part here initially was 0.3, the whole thing. So this will be 0.3 minus x. Okay, that's about it. Then this part here would be, because it was 0.25 initially, so this is 0.25. This is actually 0.25 minus x, and this would just be 0.3 minus x. Okay, then the whole thing here will just be 0.5. This 0.5 here, this 0.5 here would be 0.5 minus these three, this, and this. Okay, so because c is 0.5, so this part here will be 0.5 minus 0.25. This is 0.25. Okay, and minus of 0.3. So minus 0.2 minus 0.3 minus x. So this case here, key in calculator will be x. 0.5 minus 0.25 minus 0.3, I believe is 0.05, negative 0.05. So this is x minus 0.05. Okay, so yeah, that's about it. This case, if you want to express this in terms of x, also can, not an issue. I'm not sure whether it's like, let me see whether it's useful. This minus of this, minus of this, minus of this. Or is this minus, oh, sorry, this is initially like that, right? So is this minus of this? So this will become, this minus of this will become x. Is it? You're wrong. Wait. 0.3. Yeah. So this is x. Okay, great. So then this is 0.2. So this will be x. Yeah, there you go. Okay. Yeah, there you go. So just remember, maybe I should just put this out here. A and B, yeah. Okay, you don't need to do everything like so this is middle is 0.3, right? This is 0.3. This is 0.2. This is 0.2. Okay, you don't need to do everything out, but just eyeball lah. So like this x here, x in the middle has to be less than PA, obviously, and also less than PB, also less than PC. Okay, so because it's intersecting 3 times, or if you want, the more accurate one would be x less than 0.3, because this is 0.3. Then x should be less than, this is 0.25, and this is x less than 0.2, 0.3 as well. So obviously x has to be, to satisfy 3, you take the smallest, which is this one here. X has to be less than 0.25. So this one settled for this case here. Then the rest, you could actually make this more than 0. The upper bound is not useful because this 0.25 is this whole thing here. So the upper bound, actually don't really care the upper bound. You put a 0.25 here, it will be 0 and 0 here. This whole thing is 0.25, right? So you don't really care. But what you will get essentially is also x smaller than 0.25. So it's the same. This case here, same thing. You take 0.3 minus x bigger than 0, be less than 0.3. Because this potato here is 0.3. This one, right, is within this range here. So actually it's quite useless also. So x 0 less than, so x is less than 0.3 if you solve this. Okay, I'm not going to go into like how to solve it. I think this is like basic secondary school stuff. So all is like either 0.3 less than 0.3 or yeah. Just pick the smaller bound. Yes, pick the smaller upper bound. Yeah, smaller upper bound. Yes, because you need to satisfy all. So you pick the smallest upper bound. Okay, so once you get it ready, then you think about this one here. This is x minus 0.05. Obviously, this has to be bigger than 0. And this one, you can put less than 0.5, but actually, I think it's quite useless because the upper bound won't help in this case here. Some of you will think, Mr. Gan, how do I know when do I take the upper bound or not? But okay, even you take this, right, when you take this and this, right, you merge them on the number line. So this is 0.25, that 0.25, less than 0.25. You know that probability have to put a stop at 0 and 1. Okay, so this is 0.05 to 0.505. So it has to be this region. This is x. So hence, px, x is between 0.05 to 0.25. You get it? So this case here, we get 0.05 PA intersect B intersect C less than 0.25. So that's the answer. Yeah, it's pretty okay.